Hey guys, hope you're having a great day. So we're going to round out Unit 2 with 1.9, which is function models. You will need your calculator for this lesson, so please make sure that you have it with you. The very first thing that we're going to do is just on our calculator, I'm going to show you how to turn on what's called the diagnostic. And what that does is it produces an R value or an R squared, depending on the model, which just indicates, we'll talk about more of what that means in our next couple units, but it indicates the strength of the model. So it allows us to decide what's better, quadratic versus cubic or whatnot. So to do that, you're going to hit second 0. And you could scroll all the way down to diagnostic on. If you hit alpha and then where it's dx to the -1, that will allow you to kind of shortcut there. And then I'm going to go down to where it says diagnostic on. I'm going to hit enter and it's going to say done. So again, that'll produce your R value, your correlation coefficient, as well as your coefficient of determination, which is R squared. All right, so what we're going to do first is we're going to create a linear regression. You may have heard of this back in Math 1 of something called like a line of best fit. So this is the fresh market price of Florida oranges in dollars per box. And what I've done here is it gives me the years, but that's going to be kind of hard to graph on a scatter plot. And those years don't actually necessarily have meaning in and of themselves, more of just like the time that's passed. So I'm going to let X represent years since 2006, just to make my life and my numbers a little bit easier, a little bit smaller to work with. So to enter this data in your calculator, you're going to hit Stat. It's going to bring you to this menu. Just hit Enter for Edit. I'm going to scroll up and clear if I have anything in my list. Again, scroll up, hit Clear, and scroll back down, and it'll clear out your list for you. So I'm going to enter this data into my L1 and L2. X will go in L1, Y's will go in L2. So 0, 1, 2, 3, 4, 5, 6. And then in L2, that'll be the price per box. And always just look over and make sure that it looks good, because if you do have something like it was supposed to be $15.99, but you type $5.99, it will give you an error. Actually, it won't give you an error. It'll produce it, but it'll be wrong, if that makes sense. So once I have that data in, I'm going to go to Stat. I'm going to go over to Calc. Notice there's lots of things here. There's lots of different regressions. 4 and 8 will produce the same thing, just opposites of each other. If you end up taking AP Stats, we like to use number 8, which is A plus BX, rather than like a MX plus B sort of thing. You can also see a quadratic regression, a cubic regression, a quartic regression. LN is a logarithmic regression. Exponential, power, logistic, sine. Okay. So what we're going to do, we're trying to do a linear regression. I'm just going to use number 4 since that's what we're most used to. If you have a newer calculator, it'll pull up this menu. If it doesn't, it automatically will do L1 and L2. So L1 is my X's, L2 is my Y's. This part is important. If you don't have the menu, you can just type this in. You don't need to put it anywhere. So you can just type this straight in. I think it maybe gives you a set of parentheses. I'm not positive about that if you have an older calculator. So what I'm going to do is I'm going to hit vars. I'm going to scroll to the right where it says Y vars, enter, enter. What that's going to do is it's going to produce this line of, or linear regression, this line of best fit, and then it's going to store that equation with all the decimals into your y equals your y1 there. All right, so let's write this down. Now, one thing I'm going to add in that maybe you haven't seen before is this y hat. It just means a predicted y, okay? You see that a lot in AP statistics. If you don't put the hat, if you forget the hat in this class, it's okay. If you forget the hat in AP statistics, it's not okay. So I figure let's just introduce it now. All right, we're going to round to 3 decimal places, 0.357 plus, and if you did use option number 8, that would be fine too. That would be acceptable, plus 10.746. Whenever we write a regression model, I always want to define what X and Y are. So we already said X is years since 2006, and Y is the price of Florida oranges. So we know what we're talking about. So anytime you write a regression, this better be somewhere beside it. All right, use your function to estimate the price for a box of oranges in 2015 or 2014 and 2015. So 2014 would be X equals 8, 2015 would be X equals 9. There's a couple ways to do this. You could, since it's just x equals 8, x equals 9, if you go to second graph to look at your table, I can just go to where x equals 8 and x equals 9. If I had something a little bit bigger that maybe I didn't want to scroll that far, couple options. One, you could do second window to start your table at 8, for example. And then if I go to my table, it started at 8. The other option is, let's say even if like it was a decimal and you didn't want to deal with that, vars, y-vars, function y1, just like we did, if you put in parentheses the x value, it will produce what the y value is. I'm going to round this to 2 decimal places because we're dealing with money. So that's 1360. And then in 2015, it was 1396. Okay. The next couple pages just give you some directions for how to produce that and how to also produce your scatter plot. We won't need the scatter plot a lot, but if you did ever just want to look at the points of data, you could read through those directions. More than likely, you're not going to need that. You're just going to need the equation. But if you're kind of a visual person and want to see what's going on, that is an option as well. So let's look at a quadratic. Again, the first thing I'm going to do is define my x and y. So x is time in seconds, and y is height in inches. I'm going to go ahead and type this into my L1 and my L2. So I'm going to hit Stat, Enter for edit. I'm going to scroll up, clear, scroll up and clear. If you type over it, it'll also work to override it, but just be careful if you have an extra line from what you had before or whatnot. So let's go through and enter all of our times in our L1. And then our heights in our L2. Okay, so I'm going to go to Stat, right arrow over to Calc. I'm going to go down to Quadratic because it tells me to produce a quadratic regression. Vars, y-vars, function y1, and hit calculate. So all you need to do is basically just plug in the a for the coefficient in front of the x squared. So it's going to look like y hat, predicted y, is 0.008x squared plus, or it's really minus, but minus 2.0 x plus 123.119. Okay. And again, I've defined my x and my y. So use the model to estimate the height of the transmission fluid at 35 seconds. So that means my x is equal to 35. So I'm going to go clear this out just to get my standard screen. Vars, y-vars, function y1, and in parentheses, I'm going to put 35. And that gives me 59.723 inches. Okay. How long will it take to drain the storage tank? That means that the height is equal to 0. Or we could say that y equals 0. So how we can do this is we know this function is in my y1. I've already changed my window and I've made my x max 100. I know that y-intercept is 123 point something. So I need my y max to be higher than that, and you can kind of play around with the window. If I go to graph, I'm looking for where the height is equal to 0, or that y value. So I'm looking for that 0 right there. So second calc, go to 0. It's going to say left bound. So I'm going to hit enter somewhere to the left. Right bound, somewhere to the right, hit enter, and that's at about 87.743 seconds. And that makes sense because you can see that it's kind of decreasing in this section. Okay. All right, so now let's look at something without the calculator. So if we were trying to do this idea without a calculator. So let's go down to example 5. It says a parabola contains the points -1, 3, 2, -3, and 3, 3. I also put that in the table because you might see that in a table format. Find the equation of this parabola in standard form. So because it's a parabola, we know we just dealt with ax squared plus bx plus c. Okay, so we're essentially trying to find what a, b, and c are. Step 1 is to create a system of equations by substituting the given points. So I'm going to start with -1, 3. I'm going to plug in 3 for y and -1 for x. When I simplify that, I get 3 equals a minus b plus c. That's equation number 1. Next, I'm going to do the same thing, but I'm going to do it with 2, negative 3. And that's what I get for equation number 2. Then I'm going to do the same thing, but I'm going to do it with 3, 3. And that's equation number 3. Now, you may remember solving systems of equations back in Math 1, but a lot of times you just did it with 2 variables, so like x and y. And this time we have 3. So what we want to do first is kind of get in a system of equations with just 2 variables and help and solve that, and then we can use it to find the third. So what I'm going to do is a process called elimination I'm going to just start with these two, okay? So I'm going to stack them on top of each other. 3 equals a minus b plus c. Negative 3 equals 4a plus 2b plus c. The easiest thing to eliminate here is going to be c because they match up. If I subtract the equations, they're just going to cancel out. So I'm going to subtract these two equations. So 3 minus negative 3 gives me 6. A minus 4a is negative 3a. Negative b minus 2b is negative 3b. C minus c is 0. So here is essentially equation number 1 that I can use to find a and b. But I need a second one. So let's do it again. Let's do the exact same first equation. We could do any combination. And let's do this one right here. Okay, so 3 equals 9a plus 3b plus c. And let's subtract them. 3 minus 3 is 0. A minus 9a is negative 8a. Negative b minus 3b is negative 4b. So now I have a second equation. C minus c is 0. So now I can use these two equations to solve for a and b, okay? And then that's going to make it a little bit easier on me when I then I can use that to find c. All right, so a couple different ways you can do this. What I'm going to do maybe is let's go ahead and solve this one for a. So if I add 4b to both sides, I get 4b equals negative 8a. Actually, let's solve it for b because then it'll be a nice, pretty cool number. Divide by 4, b equals negative 2a. Okay, so that tells me the relationship between a and b. So now I can use this and I can substitute this in. Okay, this is called substitution method. And I can substitute that in. Wherever I see a b, I'm going to put negative 2a. Okay. All right, so I have 6 equals negative 3a minus negative 6a. Okay. So when I get that, okay, negative 3a minus negative 6a, that's going to be negative 3a plus 6a, which is 3a equals 6. Therefore, I get a equals 2. So we're 1/3 of the way there. Again, I used my 3 equations to bring it down to 2 by subtracting out that c, and then I solved a system of 2 equations, and so far I found a. Well, I can also pretty easily find b because b equals negative 2a, and I know that a equals 2. So b, therefore, will equal negative 4. Well, now if I have a and I have b, I can go to any of my 3 equations and find c because I know that 3 equals a minus b plus c. So 3 equals 2 minus negative 4, because that's b, plus c. 3 equals 6 plus c. So therefore, if I subtract 6 from both sides, c is equal to negative 3. Now, we don't want to lose sight of what it asked us to do. It said write the equation in standard form. So ax squared plus bx plus c. Okay, a is 2, b is negative 4, and c is negative 3. You don't need those pluses in there, but it's just a habit. Okay, so that is my equation of my parabola. Okay, I know that's a lot. There's a lot of stuff going on, but if I were you, I would make sure that you know how to do a problem like that. Okay, all right, let's do one more without a calculator. We're going to do example number 6. Okay, I'm actually going to show you how to use the calculator if I wanted to solve this as well. So it says the perimeter of a rectangular garden is 84 feet. Okay, so I'm going to call this, actually it says W, so let's use W. Okay, and it says the perimeter, which means I add up all the sides. Okay, there's 4 sides in my rectangle. Sometimes they'll give you a problem like this and they'll say one side's against a barn or against a river, so you'd only use 3. But 2W plus 2L is equal to 84, because 2W is W plus L would be equal to 84. Express the area as a function of the width. Okay, so what I can do here is take this equation and I can solve it for the length so that I get that in terms of the width. So 2L equals negative 2W plus 84. Subtract that 2W to the other side. Divide everything by 2. So L equals negative W plus 42, or 42 minus W, either way. Now, if I'm writing the expression for the area, we know area is length times width. But instead of saying length, I'm going to say negative W plus 42. And now I've written the area as a function of the width. I only have W's in my equation. You could also, if you wanted to, you could distribute this, and area equals negative W squared plus 42W. The width that maximizes the area. If you were asked for something like that, what you would need to do is you need to go into your y equals. Let me clear that out. And I'm going to do, you can't type W into here. I mean, you could, but I would just use X just to make your life a little bit easier. And I'm going to graph this. Okay, I can see that it has some maximum point over here. So I need to move my y max up to maybe let's just do 1,000 just to hopefully get it there. All right, remember, if I was going to find the maximum, second trace, go down to maximum, somewhere to the left, hit enter, somewhere to the right, hit enter. When it says guess, hit enter again. Remember, that's just a rounding error. So what this tells you is the width that produces the maximum area is 21. So the width that produces it is 21 feet, and the actual max area is 441, I believe it says. 441 feet squared. Okay, so the y value is telling you what is that actual max area, and the x value is telling you whatever you used for x. So in this case, we used W, which was our width, to represent x. So again, all this one said was writing the equation or writing the function. But if it asked you to actually find that maximum, or sometimes we're talking about minimum or anything like that, then you can do that just using your calculator. So that wraps up Unit 2, which is rational functions, transformations, and a little bit of function modeling, okay, with video 1.9. Hope you're excited. So just make sure that you have a good understanding. I would especially make sure to look back at that cubic function where you're writing that equation. That is going to be important. Hint, hint. So as long as you make sure you do that and practice, then you'll be all set, and hope you have a great day.